All right, just finished solving minimum absolute difference in a BST, and I'm gonna go ahead and walk through how I solved it. Um, Great. To find the minimum absolute difference, and mind you, this is between any two elements of the BST, it makes sense on paper to first convert BST to a list and then uh, order the list and then find the minimum by updating, right? So how do we do each one of these steps? To first convert the BST to the list, we can use this thing called an in-order traversal, where all we're saying is create this new list, which is initially empty, you know, given our tree node. So given we'd have a root, then we have a child, so on, right? We're saying suppose our in order traversal is called like a helper. It's a helper function, right? We call helper on this child, and we also call helper on this child. But in between these two statements, we're just going to go ahead and append root to our list, right? So our helper will recursively keep going down until it's a leaf node, and we're going to consider that check by doing an if node check. And all the while, it's going to be appending that specific value of that node to our resulting array and continue to recursively call everything. Finally, in fact, since the fact that this is a binary search tree and we're doing an in-order traversal, we are going to end up with an ordered list because in a binary search tree, everything is in order, in ascending order. And finally, to find the minimum, all we're going to do is compare our current minimum to the I plus 1th entry minus the ith entry and see if that new difference is smaller than our current minimum. And if so, we're going to update it. Otherwise, we are going to go ahead and pass on that. So as we can see, here's the code typed out. We have get minimum difference, initializing the minimum to be infinity. Our in order, it's just like I said, if a node does exist, we in order with node.left. To our resulting array, we append node.val, and we do it in order on node.right also. Remember to always call in order on your very root node that's passed into this array. And finally, for I in range, len res -1, because we never want to really get to that last element because we're going to compare the I plus 1th entry and the ith entry, right? If we do just len of res, it's going to cause an index out of bounds error. We just take the min of our current minimum and the difference between the I plus 1th entry and the ith entry. We do this for all the elements of our resulting array, and we just return the minimum. Hopefully that was a short educational video on binary search trees and in-order traversals. We will be using these concepts in other interview 150 problems to do with binary trees and binary search trees. So yeah, hopefully it was a useful video. Thank you guys for watching.